What would happen if a nuke went off in the Mariana Trench? This is the Tsar Bomba, the nuke that Soviet leader Nikita Khrushchev promised to show the West during the Cold War. 58.6 megatons of sheer, unadulterated power, with a subsequent blast wave that circled the globe 3 times. And this is the Mariana Trench, the deepest crack in the Earth's surface, a canyon almost 7 miles or 11 kilometers deep, up to 3 miles or 5 kilometers wide, and completely filled with water. The Tsar Bomba was dropped from a height of 6.5 miles, that's about 10.5 kilometers, which is almost equal to the depth of the Mariana Trench. Coincidence? I don't think so. So what happens if we drop a nuke into the depths of the Mariana Trench for a good and proper kaboom? Alright, so we've decided to blow up the Mariana Trench. Before answering the question, what happens, we have to figure out a method for delivering the bomb to a depth of 7 miles or 11 kilometers, and it's not as simple as you might think. After all, the density of water is 1 gram per cubic centimeter, which means that at these depths, the water pressure will reach 110 megapascals, which is 1,100 times normal atmospheric pressure. For our purposes, this means that a nuclear bomb, with the standard outer layer of lead, will simply get crushed flat, without detonating, of course. The amusing but lackluster end result would be a giant uranium pancake, 130 feet or 40 meters in diameter, ending up at the bottom of the Mariana Trench. This pancake will emit radiation for centuries, as the half-life of uranium is 2,000 years. But in this scenario, there will be no explosion. The charge won't be compressed to the point of critical mass, and the thermonuclear shell of the bomb will get torn off halfway to the bottom and dissolve in the water. So let's say the bomb will be lowered down inside a bathyscaphe. That's a deep-sea submersible designed to withstand high pressure and, optionally, be remotely controlled. In this case, we're gonna get our bang. And there's actually more than one way for that to happen. 1. If the bomb is detonated at a depth of between 3 to 5 miles, that's 5 to 8 kilometers, the explosion won't be that much different from your typical underwater nuclear test. Oh, except for a tsunami 400 feet or 122 meters high that will appear on the surface of the Pacific Ocean and completely wash away Japan and all of Southeast Asia. Also, half of Australia and the eastern regions of China will see tremendous flooding, and the U.S. Pacific coast, especially San Francisco and Los Angeles, will be besieged with waves up to 250 feet or 76 meters. Other corners of the globe will get their share too, albeit somewhat milder, relatively speaking. Also, the background radiation in the Pacific will rise slightly for a few days before going back to normal. 2. If the bomb is detonated at a depth of between 5 to 7 miles or 8 to 11 kilometers, or at the very bottom, then we'll have to take into account the fact that the Mariana Depression is located at the boundary between 2 tectonic plates, the Pacific and the Filipino. If the world's most powerful nuclear device is set off at this spot, the shockwave from the blast, reinforced by the hydrostatic effect, will produce a tremendous downward force precisely at the location of one of the lithospheric weak spots, the junction of tectonic plates. As a result, the plates will start either converging or diverging very quickly, and either option spells trouble for humankind. So, if the bomb explodes at or near the bottom, we're not going to get away with just a really big splash. The energy received at the base will be transferred to the boundaries of the tectonic plates at the speed of sound. Part of that energy will be reflected back up from the bottom of the trench to be liberated at the surface in the form of a colossal, ultra-super tsunami. Only this time, the tsunami will be just the tip of the proverbial iceberg. Next, we'll see massive magnitude 12 earthquakes occur across the entire ring of fire, which will then give rise to a second installment of mega-uber tsunamis even higher than before. We'll next be treated to a gargantuan release of magma back at the area of the explosion, and this will set off a chain of volcanic eruptions to complete the picture, lest the survivors in the highlands assume they've been given a lucky break. This volcanic activity will continue for at least a month, so expect the Earth to be assaulted with seemingly endless acid rain while the airborne ash will interfere with air travel needed for humanitarian missions, in addition to blocking out much of the light from the sun. To me, that smells an awful lot like nuclear winter, or at the very least, a couple of very cold years. Coupled with the tsunamis, the cold spell may result in globe-spanning catastrophe, with many species, including humans, ending up on the brink of extinction. There's also the possibility that a Tsar Bomba-type explosion at a depth of roughly 1.5 miles or 2.5 kilometers from the bottom of the Mariana Trench could punch a hole in the Earth's crust, sufficient to produce a magma fountain. The fountain would then form a new continent, while also bringing about the same tsunamis and environmental problems previously discussed. In addition, the tremendous impact could push the planet very slightly out of its current orbit. This will either bring us closer to the sun, where we'll thoroughly fry, with dear old Earth turning into something like a second Venus, or on the contrary, the impact might move our orbit further out, where we would descend into a kind of permanent winter. Finally, there's the possibility that so powerful an explosion at the location of a tectonic fault will simply tear the planet itself apart. The fate of humankind in that scenario is easy to see. Fortunately, however, the likelihood of any of the above happening is extremely low. As experience shows, in the end, humans are no fools. Shortly after the successful atmospheric test of the Tsar Bomba in 1963, the nuclear club countries signed in Moscow a treaty banning nuclear weapons tests in the atmosphere, in outer space, or underwater, a safeguard of sorts to prevent future catastrophes.